So take a look at number 6 in the handout. Andy is making a display by arranging 5 different types of fruit. This is in a grocery store. And it tells you that if the apples and oranges are next to each other, the number of ways to do that is A. And if the apples and oranges are not next to each other, that number of arrangements is B. And then you're asked for the true statement. This is just my way of asking you 2 questions at once. How many ways can you arrange the 5 fruits if 2 of them are together? And how many ways can you do it if 2 of them are not together? So this is the Joan and Emily problem, really. You're talking about an arrangement of 5 fruits: apples, oranges, kiwis, grapefruits, grapefruits, and bananas. Okay, but if the apples and oranges must be side by side or together, that means what we are really doing is we are arranging 4 items, which would mean there are 4 factorial ways to accomplish that, but we also need to decide on the order of the apples and oranges. So that's why we would multiply this by 2 factorial. So again, it's the Joan and Emily situation where Joan and Emily had to stand next to each other. And this works out to, I believe, 48. Okay. So there are 48 different ways for Andy to arrange the fruits so that the apples and oranges are together. Now, how do you determine the number of ways to arrange them where they are not together? The bottom line is you have to take away from the total number of arrangements the ones where they are together. So when we go back to that lesson, I had asked how many ways can Joan and Emily be together in the picture? And then the next question was, what if they've had a big fight and they do not want to be next to each other? The only way to do it is to take all of the items and arrange them, and that's 120. So how many ways are there to arrange all of the 5 types of fruit if the apples and oranges are not together? Whatever 120 minus 48 is. Does that make sense? Okay. So B will be 120, the total number of arrangements, minus 48, the ones where they are together, and that, I believe, if my arithmetic is correct, is 72. So B is bigger than A. So we are looking at B minus A being equal to some number. What is 72 minus 48? So is C not the correct answer? It is, yeah. So that we have one more step to go. We found the number where they're together, we found the number where they're not together, and the question is how do they compare? And B minus A is equal to 24. Does that make sense? Okay. Yeah. 9?
Yeah, it says there's no restrictions on this one, but the answer is 100.
Well, let's take a look at number 9. So students are making 3-digit numbers. And there are no restrictions. I mean, there is a restriction, but it's an unsaid restriction that if it's a 3-digit number, the first digit cannot be 0, right? So for number 9, we pretty much have to use the fundamental counting principle and say that there are a total of 1, 2, 3, 4, 5 options for the first digit. It can be a 3, a 4, a 5, a 6, or a 7. It says the digits cannot be repeated. Don't read number 9 and say, oh, there are no restrictions, so I'm going to ignore that. That's part of the problem. Maybe I should put here if there are no other restrictions. But the bottom line is I've used one of the digits up. I still have 5 left. And then I'm down to 4. So 5 times 5 times 4 will give you 100. Does that make sense? And by the way, I know you didn't ask about 10, but just for those of you that are looking at this right now, you cannot do 10 this way. You cannot do 10 by saying, well, I want odd numerals, right? And that means the digit at the end has to be odd, and there are 3 odd. You can't do it this way because it can't, and it has to be less than 600, right? Or more than 600? More than 600. This has to be a 6 or a 7 at the beginning. But if you already commit yourself to one of the 3 odd numbers back here, you don't know what number to write in the first blank. So what you need to do here is do 3-digit or 3-digit, where we're looking at 3-digit numbers in the 600s, and we're looking at 3-digit numbers in the 700s, and then we will add them together. Because I'm not going to write anything else, but if this first digit is a 6, then you can legitimately put one of 3 odd numbers here in the back. But if the first digit is a 7, you can't legitimately put 3. There's only one of 2 you can put. Have I helped you out? Does that make sense? Okay. So again, it's asking you actually 2 questions here, like the question we just talked about with arranging the fruits. We've got a total of 6 switches, and the first question is, how many ways can we arrange the switches? Like, arrange is the wrong word, position them. I can go on, off, on, you know. And the bottom line is, of these 6 switches, each of them has 2 positions it can be in, one of 2. So the answer to this question is going to be, for A, is going to be 2 raised to the 6, which I think is 64. So there are 64 different ways to do that. Now, that's A. B, this is tricky. You can really think of this incorrectly, and it can mess you up. 2 of the switches must be on, and the other 4 must be off. So the answer to B is that. 6 choose 2. You need to decide which of the 6 are going to be on. And you do not want to say, oh, and I need to choose which of the 4 will be off. Because, and think of it this way, there's 2 ways to think of it. This is like me saying I have this 6 people here, this group of 6 people here, and I need to choose 2 of them to go for ice cream. As soon as I choose 2 to go for ice cream, everybody else is not going for ice cream. I don't need to make that decision. The other way to look at it is you could actually say this. Of the 6 switches that are currently up for moving around, on or off, I need to choose 2 of them to be on. How many switches are left that I have to look at? 4. And of the 4 switches remaining, I need to choose 4 of them to be off. But 4 choose 4 is 1. And I hope you see that I'm talking about choosing 2 to be on. I could have said, instead, I could have said 6 choose 4. I need to choose which 4 are going to be off. But it's one or the other. And when I say one or the other, that doesn't mean you add them because I use the word or. And I don't know what 6 choose 2 is. I want to say it's 15. It is 15. So that means that there are 64 ways to arrange the switches without any restrictions. But there are only 15 where 2 are on and 4 are off, so we can subtract those and get what I think is going to be 49. Oh, no, we're not subtracting them. We just want the numbers. Is 49 the answer? Yeah, I think what I had first was, what's the difference between them? The answer should be 6415. You know what I mean? I thought it was the same one as the kind of fruit thing where we had to subtract, but I think I changed it. Is that okay?